Okay, guys, can you hear me?
Yes.
Okay, great. Welcome to the CS525. So, just to give you a quick idea about this course, mainly we're gonna try to, give credit to the slide to many resources, mainly to the Hector Garcia Molina, okay? If there's any issues in the slides, mistakes, you have to blame him, not me. Of course, you have to blame me, just to give you credit to the guy that mainly adopted the slides. Although the slides you're gonna see for every single semester are gonna be changed different from the slides from the previous semester. I'm trying to add more different slides, make sure it's gonna be easy for the student to understand what's going on. So again, what is this course? This course is just introduction to the design and implementation of desk-oriented database management system. What does it mean with the desk-oriented database management system? This means we assume that the data files is going to be organized and stored in the desk. Every time you try to access data, you have to do what? Data must somehow be available in the main memory in order to access the data. We do have another type of the database management system, which is going to be, let's say, RAM, okay? Database management system. So that's memory database management system. In this case, the data on the main subject, the main storage media for the data, then it will be in the RAM. Okay, that's a different story. Again, class is design and implementation of the desk-oriented database management system. It's not teach you how to build application, or the database application is implementation. If you're interested to learn about SQL, etc., and the database application, that means this is a good fit for you. It's going to be CS425. Since you started here, that means you are in the right class. So first, let me introduce myself. My name is Yusuf. I'm a senior lecturer here at the IIT. This is my 5th year at the IIT. It looks like the department forget that I exist. That otherwise they're gonna kick me sooner than later. Anyway, this is not the first time teaching the CS525. The first day I came to the IIT, they asked me a simple question. Can you teach advanced database organization? I said, yes. I said, okay, that's yours. And since that day, I got to stuck with this class. Don't understand me wrongly. I like this class. Are you gonna see that from my tone, especially when I start talking about during this class? You see that I'm usually get excited to teach this courses. Of course, at the same time, that's cause that my voice can be my speaker can be speed up. So if you for any reason, any time you feel that I'm speeding up, I'm speaking so fast, you can yell. It's fine, or you can interrupt me and any time say, please slow down, take it easy. I will try. Okay. So anyway, this is not the first time teaching this course. This is my email. If you're interested to send me an email, let me try to use. I think I can use my iPad. Oh, that's great. I use my iPad. Great. This is my email. If you're interested to send me, feel free to shoot me an email about the class, concern, questions. I'm not gonna apply. Of course, I'm gonna apply, but it depends on the time. My research interests rely on the data privacy and security. That's why I'm teaching database classes at the same time teaching information or cybersecurity class. Okay, this is my office. Last time I checked, still there, 237D in the Stewart building, next to the computer science department. The main office. The office hours will be Mondays, starting next week. Oh, next week we don't. I hate that. Next week we don't have a class. We'll try to figure out a way how to make it up with that class. Anyway, it's gonna be Mondays from right after the class. I'll give you 1 hour if you have any question, any concerns. We're gonna mainly use the Blackboard in order to pass the assignment. You find the lecture notes, reading material if it exists. Mainly we have some reading material, although I will try to cover everything. All what you need is going to be covered in the slides. Okay, announcement, the due dates, etc. The PIATS, I encourage you to sign up. The PIATS link is available in the syllabus. In order, for example, you have any question related to the coding assignments. Okay, I'm going to talk about the coding assignment a few minutes later. But right now, if you have any question about the class, about the coding assignment, for example, coding assignment 1, I do have this error. Of course, you have to reach out to the TAs. But at the same time, it doesn't hurt if you post your question here. Maybe someone else knows the answer. So I encourage the other student in order to participate in order to help each other. So it's going to be a good sign, and also it's going to help you in the overall participation in the class. TAs. I believe the department is going to assign 2 TAs in this class, not 1. So once we confirm this information, once they're going to assign the TAs, I'm going to provide you with this information. Okay? Good. The prerequisite of this course, when you talk about, I expect from you to know the SQL. Okay? Because later we're going to talk about the query processing and optimizations. So we're going to see that, for example, when someone tries to send the query, okay? Let's make it, yeah. When someone sends his query, okay, as a SQL, yeah, the database management system is going to do what? It's going to try to find the best plan, the best way how to execute this query. Then after that, choose the right plan. Then after that, it's going to be give you the final result. So here in this class, I'm not going to teach you how to write a SQL query, but I expect from you to know here. I'm not going to ask you a question about write SQL query in this class. You already did this one in CS4 to 5. I expect you to have programming experience in C and C++. If not, this is your chance to start looking at the C of C++. That's why when you talk about the coding assignment, I'm going to assign the coding assignment starting from today to give you time in order to look at the code to see how can you perform coding, you're working with the C++, and etc. I mean with the C, okay? Why? I'm going to provide you with the helper files, all of them written with the C. In order to handle the database management system, right? The database management system Scratch it's better to use, the C language or C++ language. Okay? Unix operating system and the file system knowledge is helpful. When I say it's helpful, it's not. I'm not gonna ask you about the Unix, okay? But what the plan in this semester here, we got as I did last semester, we do have a FOIA server is available for the computer science students here. I need just to send requests. I know that they are, I think we do have someone take care of this operation. Is going to create an account to every single student. You can use this account in order to ask Unix server in order to test your code. Yeah, if your code works there, that's fine. That means you are safe, okay? Because we have different operating system, maybe you have some incompatibility issues. Okay, so you can use that machine, that server, in order to test your code. That server, is Unix. Okay, I think you Ubuntu, if I remember. So you need to find a way how to handle the server, right? And also, it's helpful to understand the file system knowledge, how the file is going to be structured, and certainly help you actually how to navigate your way. Make sense? The lecture is going to be and the PDF is going to be available before the class. As you notice now, you know exactly what's going on today. If you get a chance to look at the slides before the class, that's great. Okay? The lecture is going to be recorded and uploaded to the course Blackboard, right after each class. That's what we're doing here. For the first 2 weeks, I'm going to be responsible for the recording. After we go back in person, it's out of my control. I'm not the person who's going to record this class. What I'm planning to do, I did this one last semester, I feel is interesting. I'm going to start to have a live session when you get back in the person. Okay? So give you a chance, even for the online student, because you have online sections here, to can attend the class on time, on the actual time, on the real time, with them in person. Or if you are registered as in person, yeah, in the section 1, and for many reasons, for any reason, whatever reason you have, you're busy, you work, you're afraid to get, COVID, whatever, you can stay at home and you can watch the lecture online. That's fine. You can, participate in the class. I will try to do this one because I did this one last semester and I feel that's interesting, so it doesn't hurt to do this one again in this semester. The quality and etc. is out of my control. I am not the person going to be responsible after we get back in person for recording the class. Expect the quality is not going to be similar to today's quality because here you're recording using my machine, my own software. And IT, they use weird software and the quality of the voice always bad. Anyway. So what I expect from you, attend the person lectures, please, if you can. Okay? I promise you, I will bring chocolate in person as I did last time, so kind of encouraging you to be in the class. Be active and please do the programming assignment or the coding assignment on time. Don't be tricked to say, oh, the coding assignment give you for every single coding assignment, you do have 1 month to finish. Yes, but if you don't start early, you cannot finish on time. Yeah, so I have to start early. I don't know who wrote this one, not me. I swear to God, I'm not the one who wrote that. Not me. I don't know what's this, but it's not me. Or maybe I was excited somehow. I moved, because you know me, I'm moving my hand everywhere. So maybe somehow I did that. Anyway, so please do the programming assignment on time. Study the exams. Okay? Be honest. This is the most important thing. For the course selves, hopefully you get a chance to take a look at this one. If not, please use a chance to look at it. It's very important to take a look at the syllabus of any course, especially for the first 2 weeks, in order to decide whether this course makes sense to you or not, whether interesting to take this course, or maybe this course is a waste of time for you, so don't do it. You see that you have to just take a look at this one and make sure that you're all on the safe side. The most important slide in this part, the workload and the grading, how I grade the class. Good news for you, to you guys, I'm doing curving. I give extra credit in the top of the 100. So last will give you a few extra points, plus curving, do my best in order to get good score here in this class. As long as you do your work, I'm trying to do my best in order to make sure that everyone can be succeed in this class. So all the scheduled important dates can be in the blackboard, in the Piazza. I'm gonna add this one in the Piazza, hopefully. Okay, it's gonna be in the cells, and this is the slides. Yeah, the programming assignments, we do have 4 coding assignments. The first and the second one, each of them, they're worth 10%. The third and the fourth is gonna be each of them, they're worth 15%. I wanted to see, last semester we have an issue because not every single student managed to finish coding assignment in time. What I did, I rescheduled this one, I changed this one. I brought the coding assignment forward, there'll be an extra credit, and redistribute the points among the other coding assignments. So right now, let's do this one. If we have an issue, we can change this one. So don't mad at me later say, oh, he changed the workload and the grading criteria. No, because we have to at the time. So right now, that's the plan. If something happened, we can adjust that. Okay? And thanks God is great. It's recorded right now. In the coding assignment, you have to have a group of, let's say, 3 students at most. You cannot exceed 3 students. If you want to work alone, that's your you're responsible. You're big boy, big boy. No, sorry, I have kids. Yeah, by the way, in a few minutes, the background, you're gonna hear, but the background, my kids start screaming, yelling because they're trying to go back from the school. So let's do this one faster before they arrive. So anyway, so the group is of 3 students at most. If you want to work by yourself, that's fine. But please don't change your mind after 3 months. You say, or 2 months, you say, coding assignment 3 is hard. I cannot do it by myself. At the same time, I cannot find another group, okay? So think wisely, choose wisely, okay? How can you decide to determine the groups? I will give you up to Tuesday, okay, January 18th, midnight, in order to decide your groups. So what I'm gonna do today, or tomorrow, let's say tomorrow, I'm gonna send you like a shared Google document. In the shared Google document, you're gonna find out something like this. You're gonna have to say, I think I can write this one here. Let me check it. Oh yeah. So in the shared Google document, you're gonna find a way to write, for example, group 1, group 2. You have a space, which group you're gonna choose, regardless, whatever. You're gonna see student name, 1, 2, 3. You can write your names here and your email. Yeah. If you want to work alone, you can say, for example, write your name here, and in the note here, I would prefer to work alone. So anyone else who try to find a group, oh, this guy wants to go by himself. I'm not gonna choose this one. And if you have one group, have 1 or 2 members, you can add your name. If you don't know anyone, you can use the Blackboard, send email to everyone and say, hey, I'm looking for a group to join. I don't know anyone. I have experience, for example, working with the C or C++ before, something like this. Then send email to everyone else. So anyone else may be looking for 1 extra person to work with their other groups, they can contact you. Make it easier for you. If you don't assign groups up to the next week, in this case, so I'm going to take a look see who doesn't find the group. I'm going to do this one randomly. Don't enforce me to do that. Okay, it's easy to use, give you a chance to choose whatever group that you want to work with. Okay? So I will, as I mentioned, I will send you the shared document tomorrow morning. Yeah. Let's be back to my slides here in order to make sure that we're on the same side here. Yeah, we did this one here. Okay? The quiz is like, we're gonna have 2 quizzes. And the good thing is the quiz is gonna prepare you for the midterm and the final exam. So the quiz one is gonna be before the midterm. So once they're gonna be take-home exam, do this one by yourself. It's easy one. By the way, in my exams, I'm not gonna surprise you with the weird questions. All the questions will be covered in the midterm. I mean the quiz and the midterm and the final. So I'm not gonna give you the question you never saw before. Yeah, I'm not gonna surprise you. Everything gonna be covered in the quiz. So once you solve the quiz, then you didn't have a problem with the midterm and the final exam. Okay, so 2 quizzes, both of them worth 5%. We do have exams, midterms and the final. Both of them are gonna be like, closed book, closed notes. As you mentioned before, if you know me, I hate memorizing. I cannot memorize. The only thing I can memorize, of course, my name, my wife's birthday. Otherwise, it's gonna be trouble. In this case, you forget that. So I'm going to allow you to have 1 sheet. If someone sees you say, I can't memorize the stuff, for example, we have some formula, especially for the coding. We talk about the quiz 2 of the last part of the class. We have many formulas you need to help us in order to estimate the cost of the query. So it doesn't hurt if you write this one on 1 piece of paper. Okay, although there is no need to memorize because it's easy to derive. Okay, anyway, the first midterm is going to be this date. I think, hopefully I'm the first person, this is the first day in the semester. Hopefully no one else has the midterm at the same time. Okay, and the final is going to be, I think, within the first week, in the May. I'm not the person who's going to be responsible. I don't have any control about the final exam date and time. So the registrar office is going to take care of this one. The midterm worth 15% and the final worth 30%. Okay, I think we have correct. Yeah. Okay. The grade distribution, A is going to start from 80. I know this class is demanding, okay, because you have to do a lot of work. You're going to do 4 coding assignments. It's time consuming. I know all these coding assignments. So at least it's going to be easy to get A to 80%. Okay? Hopefully all of you get A. Doesn't hurt me if all of you get A, but it hurts me when I say emotionally if no one get A, of course. Yeah? Good. Now the most important thing. What about the programming assignment? We're going to have 4 coding assignments here. Okay? Or programming assignments. It's going to be built one at the top of each other. One at the top. So you have one first coding assignment, then you're going to build the second one. We start with the storage manager, and you start implementing your own tiny database-like system from scratch. I will provide you with the helper file. I will provide you with the say for every single coding assignment, the description. What kind of helper file .h file do you have? What kind of functionality you expect from you or method you need to implement? Okay, give you description. I will provide you with the short tutorial for every single coding assignment. This short tutorial, especially the first one, is conducted by one of my TAs a few years ago. She was amazing and she did great. I like this tutorial because it's going to help everyone to understand what's going on in that one. And that short tutorial, especially the first one, I'm going to be uploaded hopefully today, I guess today, yeah. I need just right after the class, I will do this one in order to make sure that everyone can start looking at the coding assignment. Don't be mad at me and say, oh, the first day we have a coding assignment. I give you more time because now you can take a look to see the code. If you don't know C, now your chance to learn, to go over this one quick. Okay? So anyway, the short tutorial, the first one, is going to help you, for example, how to do running your code, how you debug your code, how to figure out whether there is a memory leak. We don't need from you to have a memory leak in your code. Okay? So all the concepts that you're looking for, the data structure that you need, it's going to be covered in the class. So you're not going to be surprised that I never know how the buffer boot, for example, works. No, we cover this one in the class. Each assignment we have for each of them, they have maybe it's going to have one extra part. extra. If you do this one, you're gonna get 5% extra. So for example, if the coding assignment were worth, for example, 10%, you got 100. Okay, and you did the extra part, you're gonna get 105 over 100. Right? So you're gonna have 5 extra points on the top of this one. Okay. All assignments must be implemented using C language, C or C++. Okay. For every single assignment, you're gonna have like test case. If you test these, you just run your code. After you write your code, run the test file. If the test file passes, then you don't have problem. If not, you know exactly what's the problem or function you need to fix. Okay? If you write extra, let's say, function or functionality added to this code, you can add your own test. To the case to that test files. Usually, we're going to use a get repository or whatever repository in order to perform this, in order to submit your code. So we'll leave this one after the way that how to submit your code, creating a repository. I will delay talking about this one until we have a TA. I need to discuss tell the TA what they're doing. Then the TA is going to contact you in order to show you, for example, how do you deliver the code, okay, for your coding assignment. By the way, remember the shared folder file that I'm going to share it with you, document file, sorry, that I'm going to share you, that allow you in order to form groups. And this one, I'm going to add one column. After we have 2 TAs, I'm going to assign, for every number of groups, you must have 1 TA to work with. Because we have now almost 90 students, I guess, registered to the class. Oh, yeah, almost 90. So I'm going to distribute the student among the TAs, so at least we have more time to contact the TA. Okay? So what the coding assignment here? So you see that storage manager, buffer manager, record manager, and the B+ index. Let me talk about this one here a little bit here. I need to clean this one here, erase. So just I'm going to show you, talk about the desk-oriented database management system. Then after that, we're going to show you what we try to plan to cover this class. Then what the relation between what we cover and the coding assignment that we need to perform, okay? So first of all here, we talk about the desk-oriented database management system. So what does that mean here? That means the database is going to be on disk. All the data can be stored in the disk, okay? And the data in the database file is organized into pages of the block. So for example, if you have a student relation, if you have a student ID, name, and so on, this is a file, yeah? So you need to store this one into the disk. This one is going to be breaked or organized into pages or blocks. I'm going to cover this one in more details later. So the page is going to be stored in the disk. So in the lower level here, we're going to have, let's say we have a desk here, your desk, and then the desk is going to have what? This is what the data are going to be stored in the desk. These files or this relation are going to be stored in the blocks. Will it have a fixed length? Let's say 4 kilobytes each. Okay, the organization, how it looks like, that's a different story. But as you assume that you have a blocks, if you have you cover this one in the operating system, right? You know the data is going to have like a page, and the page is going to be stored in the disk, right? Every time you try to fetch the block, the page, you're going to fetch this one in the memory in order to perform whatever, the assignment, the task that you're going to perform here. Okay, let me draw this one in a neat way, so it's going to be a nice way to understand how it works. So anyway, we have one block here, we have a block 2, and we have a block 3, and etc. It depends number of blocks. In order to navigate my way to see that since we have many relations, many files going to be stored on the disk, we need to figure out a way, how can you find out all the blocks of the page that relate to the specific file? Or in other words, when you say file, you say a relation or table, okay? So in this case, we do have one way database management system. We need to do that. We're going to do this one using what is called, the page directory, or the directory page. We have like a special page, we call this one directory page, which is going to be navigate to help me to find my way, which the blocks of page, where can I find the page that belongs to any file. Or for example, if I'm looking for page 16, whether the page 16 is exist or not. Okay, so the first one here, we're going to talk about this, the disk. Within our coding assignment, we're going to do the storage manager, which is going to be the first coding assignment. How can you build the file? How to organize the file into blocks. Then after that, in order to operate on data, on database, okay, or the database system that we have, the database management system required or needs in order to take this or bring this data into the memory. The same thing if you have any code, any programming language. You store the code in the disk. When you try to run this code, you have to fetch this one to the main memory, right? Here we have something is called buffer pool of the memory. So the first part is going to be the disk, and here the second part is going to be the memory. And let's see the programming assignment one. Cover this one. And we're going to talk about this one starting next lecture, okay? So we're going to cover the theoretical part, and theory behind this one. I will show you what the current database management system, modern database management system, what their current approach in order to store the data, which one the best. In our coding assignment, we're going to have the simple way to implement this one, not the sophisticated way, okay? So in the memory, since when you try to operate on any data, the database management system is going to bring this data into the memory. And doing this one by using what is called the buffer pool. So we have here something is called buffer pool. So that means here in this case you have a limit, specific memory location is limited, is not larger than or large like I'm not going to consume the entire memory in order to assign this one to be the buffer pool, otherwise I don't have other space in order to run my code. Alright, so the buffer pool is going to do what? Whatever you're looking for, example, I need specific page. So the buffer pool is going to, the system or the engine, query engine, check the buffer pool. Do we have page 2 here? No, since we have assumed that the buffer pool allow me in order to store only 2 pages. Okay, so 1 page and 1 page here. So check this one. If this page does not exist, the buffer pool is going to do what? It's going to try to find a way in order to fetch this page from the disk to the main memory. If the buffer pool has a space to store the new page, then that's fine. If not, the buffer pool is going to perform what's called the replacement policy. That's me trying to find a way in order to free space to the new block. Okay? So we are going to cover these mechanisms, and in your case, this is the second coding assignment. You're going to see how can you fetch. You see that it's going to be the coding assignment is going to be written in the top of each other, or building the top of each other. You have first the store manager, how to store the file in the blocks or page. By the way, when you talk about the blocks or page, I treat them similarly, the same thing. Okay? Fetch this one in the main memory as long as needed, if you need it. So here, when you find the page does not exist, you have to do a replacement policy, find the page in the main memory on the disk, and fetch in the buffer pool. If there is no space, you have to do a replacement policy. Okay? What does that mean, replacement policy? What if we have this page is already there, and now we need to get rid of this page in order to insert a new page instead of this one in the buffer pool? If one process or query already modified this page, I need to reflect first, right, the change of the page, the disk. Then after that, before I get rid of this one, because I replaced with another page, right? That's what is called the replacement policy. We are going to cover this one when you talk about the buffer pool. This is going to be the second coding assignment. Okay? Then the third coding assignment, what you need to do here, I need to find a way, since we have a file, and the file have like records stored in this file, right? How can I store this record inside the page or the block in the disk? What we have for the student, for example, here, we have a student ID, we have a name. For example, we have a GPA, okay? Student ID, for example, 100, name, the be Alice, and the department of computer science. Let's say A100, yeah? This will use the A number. And we have a number of students here. For every single record, I need to store this one somehow in the disk. In the disk, the only thing they understand bytes. This is we have a bit 01 or byte in order to store the data. So I need to find a way in a record manager. You need to find a way in order to convert this data somehow in the way that can be stored as a sequence bytes. But when you convert this one, you need to find a way how can we re-interpret, how to get once we have a fetch sequence of bytes, the database management system must know exactly how can we reconstruct the record. For example, in this case, maybe I'm going to use, for example, 1, 2, 3, 4 bytes. I'm going to assign 4 bytes, for example, in order to store the ID. Then a name, assume that we have stored 10 bytes for the name. Then after that, for the GPA, I'm going to store 5 bytes, for example, to store the data. Yeah. So here at the end, we have 5, 10, 4, let's say 5, 5, 10. It'll be easy, we have 20 bytes to store the data, right? Each record. So you have to convert somehow the sequence of bytes. Then after that is when it's going to be stored in the block. Now, this is, the third coding assignment. You have the sequence, how to store the record in the desk. Then after that, once you read the data, you need to figure out a way how to interpret this one, how to figure out a way the actual content of the data. Then once you retrieve this sequence of bytes, you're going to find a way how, we have the first 5 bytes is going to be, this is the student ID, the second 10 bytes is going to be the Alice, and the last 5 bytes is going to be, for example, the name, and the last 5 bytes is going to be the computer science. Don't worry, by the way, I just to give you an idea what's going on. We are going to go over each step with more details, or in details. Just now, right now, we need to make sure that we're on the same page. What your expectation, what the coding assignment going to be here, then at the same time, how they're going to be organized each other, on the top of each other. Okay? Then we have the fourth coding assignment. Of course, here, by the way, when we talk about the database here, how the database achieves this goal here, at the high-level design for the database management to support the database that exceed the amount of the memory available. So all my data cannot fit in the memory. If it can fit, then done. Don't have problem. If it cannot fit, they need to find a way in order to find what. Every time we have a multiple queries, I want to say query engines, I'm going to execute, you have multiple users, for example, access my system, each of them you need a piece of information. I need to find a way in order, everyone looking for the data, I'm going to say, here you go, that's your data that you're looking for. This is not easy job. Okay, because they have a limited space in the buffer pool. That's why we have some sophisticated technique, data structure, the way how can you build the buffer pool in the way, or I mean, sorry, in how can you organize the data on my desk in the way that I'm going to reduce or minimize the stall. Everyone's the query looking for the page, why the page was not ready or not available in the main memory. Okay, the last coding assignment is going to take a lot away. How can we speed up access to the data? We're going to talk about the B+3. So you can build your index, and your index allow you in order to access your data. Let's give you an example here. For example, if you try to access, for example, I need to perform sequential scan for the relation student. You know what you mean sequential scan? Yeah, we're going to cover this one later. Sequential scan does mean I need to read the entire relation. Okay, in the entire relation, assume the relation is going to have a block 1, 2, 3, 4. I need to retrieve all these blocks, yeah, one at a time in order to perform this sequential scan. After, if you assume that the blocks 1 up to 4 contains the information that relates to the relation student. Okay, so in this case, I know exactly where the blocks that I need to perform, right? So I can access these blocks. What if I'm looking for, let's say, the record or the student have a specific ID? So it looks like I will give you the student ID and you figure out which is the block that contains the student or record. Will bring the information related to the student. Okay? If I don't have an index, what I need to do here, I have to scan the entire blocks. Alright? Because I don't have options here. So I have to scan the entire blocks here because I need to access the block 1, 2, 3, 4 in order to figure out where the block exists. Right? If I have an index, what the index is going to see? I'm going to build an index. An index based on the ID, and here is going to be the block number, for example. If you have a specific ID, for example, ID A100, bring the block 1. If the ID, for example, 200, you're going to find the data in the block 5, something like this. So instead of reading the entire blocks, which is going to perform sequential scan, which is going to be expensive operation, I can do what? Consult this one, the index that I already have, and then this is going to tell me, for example, okay, the search prompt the index in order to tell you which block you need to retrieve. So instead you have retrieved, for example, 4 blocks and 100 blocks, I'm going to retrieve only 1 block. You see that's how to speed up the action. This is going to be the fourth coding assignment. Don't be scared. Don't be worried. Still managed to finish all these coding assignments. It's doable. The only difference here, you need just to make sure that you understand how to work with the C. Then, pay attention to the class. How can you cover, at least the theory behind this one? Then once you understand the theory, for example, if you understand, we have the relation or file divided into blocks, then in this case, it's going to be easy for you to how to handle this one, right? For example, the buffer pool, if you understand how the buffer pool is going to be works, so it's going to be much easier if you understand, okay, buffer pool works like this, we have a memory location, and it's going to exchange the data between the memory and this place, so it's going to be much easier for you to understand what's going on. Make sense to you guys? You're still with me, right?
Yes.
Okay, great. Because it's quiet. No one replied to me. I feel like everyone leaving the class. Please don't leave the class, okay? At least let's give you the chance to go over the whole thing. Anyway, so you see that assigned one is storage manager, buffer manager, then after that the record manager, then after that the P+3. And all of them can be topping each other. So in the second coding assignment, when you try to access the data from the storage manager, or you have a block, you're gonna use your code that you implement in the storage manager one. When you perform the record manager, you have to fetch blocks to the main memory, to the buffer pool from the memory, from the desk. So you have to use the buffer pool that you have here, and you have to use the storage manager. Added it. Okay. Back to the course policy here. We talk about the makeup exams here. Hopefully, unless you're sick, okay? One semester, one student sent me an email and said he cannot attend the exam because he slept. It's not excuse. Especially the exam is gonna be, usually this class is gonna be at 4 o'clock, 3:15 or 3:35. So it's gonna be afternoon. It's not in the early morning. So please, unless you have health reason, issues, try to stack, with the exam time, because for me it's hard to perform multiple exams. I do have students in China, so I have a different sections. I usually do 2 different exams. Now if you give you a makeup exam, I'm gonna do 3rd exams. It's gonna be too much for me. By the way, the TAs is gonna be responsible for the grading of the coding assignment. Okay? And the quizzes. For the midterm, the final exam is my responsibility. I'm the one who's grading the midterm and the final. If you have any question or late in the coding assignment, please reach out to the TA and CC me at the same time. Don't jump to me too directly, okay? Go through the TA first. And the TA is gonna answer your query, okay, or questions. Okay? Once the TA is gonna grade your, the coding assignment, I'm gonna go over this one again in order to check the plagiarism. If we found the plagiarism, which I hate to talk about it, this means we're gonna have a big problem here. Okay? Please be honest. Don't copy your code. If you copy your code, you're gonna be in big trouble. Okay? So it's clearly in this course we are going to go over the file organization. How can we store the data? You have the data, we will store the data in the database. So the database file is going to be organized into blocks or pages. It's going to be stored in the desk as a file manager, how to organize the file organization. Then we're going to take a look at the buffer management that allow me how to fetch the data back and forth from the disk to the main memory once the query or the query engine required or asks for this page. We're going to take a look at the performance analysis in the storage management. We're going to take a look, the query optimization transaction in general. Actually, what does that mean here? When someone was query or someone asks or send a query, how the database management system take a look to find the best way in order to execute the query. We're going to see how can you perform this operation, what the database management or the current or the modern database management system doing these days in order to speed up the act, in order to speed up the optimization of the query. By the way, right now, whatever we try to cover the class, we spend months to cover, which is going to be, less than a few microseconds once you send your query until you get your result, okay? We're going to take a look at the transaction management and the recovery and the recovery and concurrency control. We have a multiple user try to access the data, right? So how can the database management handle this one? Based on what? We're going to see, remember, we try to implement database management system. Although we are not going to do this one coding assignment, but we are going to cover, see theoretically how the database management achieves this goal. Locks, yeah. It looks like we have multiple transactions. User try to access the same piece of information for updating, for writing. So the system is going to do what? The simple solution, you can say, once the first one accesses this piece of information to modify, I'm going to lock it. No one can access it until the current transaction done its work. Then after that, I'm going to unlock so you can get the second one. I'm going to see how to see the schedule and so it looks like similar to what we cover in the operating system, but we're going to take a look to see how the database management system do this one. Recovery, okay? So what does that mean here? Assume that you need to transfer, for example, I like this example. You transfer, say, $1,000 from account A to account B, okay? You transfer the money. Okay, what if you, so the symbol transaction, try to perform this operation, you gotta do the following. You gotta deduct, for example, take the balance minus 100. They say A balance, okay? Remove 100. Then after that, you go to the balance B balance plus 100, all right? What if after you deduct or deduct $100 from the account A, the system crash? How can we recover from this kind of error? That's what it's called, the recovery. Okay, you see how the database management system what kind of mechanisms they're going to be in the place in order to achieve this goal, to make sure the system is going to be returned to the most recent consistent state, or recover from this kind. And more when the time permits, and never the time permits to add more. So actually I'm struggling sometimes. I cannot cover the concurrency or the recovery control. This semester the plan I'm going to cover them. What does that mean? That means I'm trying to reduce the material that we're going to cover in the class. So reduce the number of slides, okay? And speak faster. No, it's not a good solution, but maybe, try to do that. The course objective is clearly that after attending the class, you understand the design decision behind the textbook database management system, the plan as I did this one before. What I'm going to do is going to try to find out, for example, what the current database management system doing, why they did do this one, why they did this is their solution, because they tried to achieve this goal. Try to compare, I'll give example related to the, let's say, open source database management system and the commercial one, the expensive one. Okay? What's the trade-off between the different ways in order to store the organization technique and store the data on the desk? In other words, we try to store something in the desk. Remember that we said the file, it's going to be the database file, it's going to be organized as a sequence of pages of blocks. Okay, the way that you organize your blocks, it's going to have affect the overall performance. If you go with the low level here, and you have your data, for example, and the blocks that you're going to perform here, see the relation R that has, for example, block 1 up to block 10. If I randomly just store the block 1 to block 10 everywhere, you know that you're going to see that it's a desk-oriented database management system. The data can be stored in the desk. At the desk, you're going to talk about this one next lecture. You're going to have like a tracks, and each track can have like cylinders or tracks, and you have different places. Okay, so maybe the blocks are going to be distributed everywhere. It looks like you have a number of students, and you distribute them randomly in the class. When you try to collect them or pass over all of them, you see that maybe you're going to scan the entire class in order to scan or go over every single student, right? But if you find a way in organizing data, instead you have to redistribute the data randomly, maybe you're going to say, I'm going to reserve maybe the first rows in the class in order to see, the student that belongs to this class or specific class, or the student that belongs to the same department, for example. So it's easy for me to navigate your day my way, right? So that's the way how to organize your data. I'm going to take a lot of different techniques. We're going to hopefully going to be able to build parts of the small site data processing system from scratch with the database management system. We're going to have 4 tasks. Of course, these 4 tasks is just simple tasks that the database management system can perform. Understand the basic of the query optimization. What does that mean, query optimization? That means what does actual database management system doing in order to find out the best efficient way in order to execute the fastest, the less expensive way in order to, when say less expensive, that means from the time and the resource allow you in order to execute the query. Okay? Let me give you a quick example here. For example, what if we have, for example, query to perform R? You write this one using the relational algebra because it's easy to understand. Assume that we have R as a Cartesian product, then after that selection based attribute A that belongs to the relation R and A. Let's say A greater than A dot R, or let's say R dot A is less than or equal, let's say R dot B. Okay? This one query. So that's in this case, the plan you're going to perform Cartesian product. Then after that, do the selection, right? Cartesian product is expensive. What if another plan, the system is going to say, okay, it looks like since based on the common attributes, maybe we're going to perform natural join. So I'm going to do what? R natural join, you say, yes, and then done. And the top, I'm going to give you the same result. But the way that execute this one can be different because you have two different plans. You see that? So doing that natural drawing much faster than doing the Cartesian product based on in our implementation. So hopefully by the end of this class, you can understand how the basic query optimization, you can tell, for example, which one is going to be, how the system is going to decide which plan is going to be choose, which one is going to be fast, based on what, too. And the same thing here, we can take a look at what's the actual implementation when we perform natural drawing here. We're going to see that, or join in general. We do have, you know the join, right? We're going to perform like combine tuple or record belongs to two different tables based on the specific attribute, depends on the condition that we have, the theta join and natural join, right? So we do have many algorithms, many techniques, many ways in order to implement the join. So we're going to navigate all over, mainly we're going to focus on natural join and give you 5 different techniques, mechanisms, algorithms in order to implement the natural join, and each of them is going to have the advantage and disadvantage. And the system tried to choose one of them based on the data and the resource available. Okay? Be able to estimate the cost of executing query operator based on the database management statistics. You see that here later. When you have 2 plans, we say, well, 2 different plans. For example, if I say R join S, then after that, for example, join, let's say, perform selection, or maybe the R selection, for example, with S, then after that, natural join. Sorry, with S. Something like this. We do have a different plan. How can we estimate which one is going to be fast? The easy way to estimate, find out the cost of the plan, to execute each of them, then after that, to compare the cost, which does make sense. Right? Because if we're going to execute all of them, we're going to see some query, we're going to have millions of plans. So it does make sense to execute, to find which one the fastest, then after that to say, oh, yeah, true, this one is the fastest. Does make sense. So in this case, we find a way how to estimate the cost. We're going to see which one is going to make sense based on the statistical information that's available. For example, how many tuples do you have in this relation? How many unique attribute value for the specific attributes, and etc. How many blocks required to store the entire relation? And so you see that different type of information, what the minimum, the maximum value for the specific attribute in this each relation. So based on this information, you can have a better estimation which one is gonna be, which one a query plan you're gonna choose. Make sense? You're gonna take a look at different, say, indexing techniques. We're gonna talk about the hash indexing and the B+ indexing. Okay, which the simple main indexing techniques. The B+ tree, by the way, is still used until today. Yeah, which is going to be B tree. If you have a B tree, take a look. You know that when you create an index, you have a chance, opportunity in order to choose which index technique we're going to use, all right? By default, if you don't specify whatever indexing technique, the system is going to, by default, use most of the database management, if not all of them. I need to be safe to say not most of them, and going to use the B+ tree. Yeah, so we're going to see how the indexing technique. By understanding the indexing technique, you're going to see what's going on with the system here. And also how do you take a look to understand the concurrency control, how the database management system actually, we know when you define the database management system, we know exactly how the database management theoretically at the high level, we say the database management system has a technique in order to achieve the concurrency control, which is going to be achieve the concurrency control. Allow us compare the database management system using the file system in order to host the data, because we have this kind of feature. But now we're going to take a look with Debo. Take a look. This looks like low level, yeah? So what the database management system actually is going to do, and how can it achieve the concurrency control and the recovery mechanism in case the system crashes. Okay? So that's what the planning to cover. It depends on the time, it depends on the speed, it depends on, say, whatever we have. We have holiday, we have off day, we have, say, whatever. So I estimate that this is the plan that we try to cover. Hopefully we'll try to follow this one. The textbook required, there's no require, there's many textbook, but don't worry, because I'm gonna give you, all you need in the slides. Okay, I'll cover everything in the class. Okay, if you want, you can find different textbook, but for me, it's easy to, follow the class and do the coding assigned, because you see 50% the coding assigned, which that's required for you to read the textbook, unless you want to learn more. This is one of the important slides. So please don't send me email and say when the final midterm exam is going to be. It's here. So here's this is the plan right now, okay? The coding assignment, I will assign this one today. It's going to be available in the assignment. I'm going to create, folder for the coding assignment. I'm going to be coding assignment 1. You're going to find the helper files for the coding assignment 1, the description, and what to expect, what you need to perform. Then after that, you're going to find, another file which have the tutorial, short tutorial. Take a look at the short tutorial first. Watch this one, 5 to 10 minutes maximum. All the show, I think the tutorial is going to range between 5 to 10 minutes maximum. Watch this tutorial first before do anything. Then after that, start from right now, form groups. Then after that, you need to get used how to work with the C language. So choose the time. You need to use the time wisely. The due date is going to be in the February 4th. Now if you want to say, oh, 1 month, no, it's not enough. Don't wait until the last minute. Start early, to be honest. To have enough time. I try to have like 1 month, almost 1 month for each single coding assignment. The third and the fourth coding assignment will be more complex than the second and the first. The first one's supposed to be the easy one. So you have time to familiarize yourself, to get used to the language, see how to work with, and to find the group. Yeah, for every single coding assignment, after you submit, in order to make sure that everyone works in the coding assignment. So the plan here, as it did in the previous semester and each semester, teacher's course, you have to fill what is called, the serve and bear evaluation form for every single coding assignment. So once you're done, submit the coding assignment 1, you have 3 members, right? You need to evaluate your work, what you did, and what the other member did. If one member didn't participate, this guy, he or she will not get the same score as you. It might be get 0. If you don't work, you are not going to get anything. If you start working, for example, 1 week, or the second week, for example, 2 weeks now working the coding assignment 1, don't wait until the last minute, until you perform the submission. You can reach me out, or reach out the UTA, and CC me at the same time and say, we do have a problem. We cannot work together. For example, now we have an early, we can try to fix this one early. Don't wait until the last minute. Okay, so I'm begging you, please start early working in the coding assignment. Okay, so this is, you see that for the quiz 1, this is the plan for the quiz 1. This is, the due date. I give you a few days to finish the quiz 1. It's take-home exam. It's easy and help you to prepare. If you answer the question, the quiz, then the midterm will be similar question. Similar format, not a question, format, structure. Of course, not the same questions. For the quiz 2, it's going to be this date before the final exam. And this is the midterm and the final exam. And this is, our plan. Maybe we need to adjust this one. It depends on the time, the complexity of the coding assignment, etc. Maybe we need to adjust this time. Okay, so that's why I said this is very important slide. You can take a picture for this slide, put it in your phone. So every time you send me email about when the coding assignment 2 is going to be due date, when the quiz 1 is going to be, you can just take a look at the slide. It's available. It's going to be in the syllabus, and the first will be in the course description. Okay, that's all about the first part of today's lecture, about the course organization. Do you have any questions? Any concerns? Something is not clear? Something that you don't like? Feel free to reach me out even after the class. Okay, so now we need to go to the introduction. So now starting looking at, the subject in more details. So I will try to, this is the introduction part. So here just try to convince you, find a way to tell you that this class is not a waste of time. That's the plan of today, this part of lecture. Okay, so we got an introduction to the database management system implementation here. We do have a core terminology. I'm not going to go over this one. You know that, for example, what do you mean by data? What do you mean by the database? We talk about the relational database. You know what do you mean by the query? The extract the specific information from the data. You know what do you mean by the relation or the table? Okay, you know what do you mean by the schema, because I'm gonna say later, starting with today, I'm gonna say we take a look at the schema, with relation, etc. So we need to make sure that all of us are in the same page. Okay. So when you talk about the database management system here, or the database is an organized collection of interrelated data that models some aspect of the real world, right? This is a database. I'm talking about the database file. For example, it might be modeling the student in the class or in the university, and etc. Right? People often confuse the database with the database management system. When you talk about database management system, database people say it's the same thing. No, it's not the same thing. The database is the data itself, and the database system or the database management system, which is defined as what? Is the software, a set of software that manage the database. This is a simple definition. So the database management system or the database system is like, example, MySQL, Oracle, SQL Server, whatever. All of them are an example of the database management system. Okay, so we have a set of software that would allow me in order to manage this database in a more efficient and convenient way. This is the most important thing. Efficient and convenient way. Okay? So, what advanced database organization? What this course? This course we have is talk about the database implementation. How can we create the database management system in general? Okay, how to implement a database system, and hopefully have fun doing it. At least I have fun when I teach this class. Hopefully, guys, you have fun working with this one. Hopefully, you're gonna learn something interesting, something different, something gonna help you if you decide to work in the database implementation system. Maybe you're gonna find a job in the Oracle or MySQL or whatever, or Postgres or starting building the database management system, the low level. Okay, so the question is, what works for the database? Someone is gonna say, okay, the only thing you need what? I give you like a simple functionality from the jobs or functionality of database management system. I didn't list all of them. I list these features for a reason, okay? So what we have, the database management system will do that. Keep the data around, persistent. Whatever I'm gonna store, if you want, come back the next day, I'm gonna retrieve the same piece of information. Nothing will change. Of course, assume the data is intact. No one maliciously modified the data. I didn't perform any query. So whatever you're gonna store in the data, you're gonna find it later. It's gonna be the data persistent. Right? Okay, easy. I can store my data in files. That's the meaning, all right? The second one, answer queries or questions. So you send something and retrieve some data. Okay, it's doable. The third one is update data. Allow me in order to update, modify the data. Okay, so in this case, I'm not convinced. Why need a database management system? I do have looks-like relation, tables. I can build this one in the table or in the files. Whatever file system that you have, text file or CSV file or whatever, then in order to extract the data, I can build Java code or whatever, allow me to simulate the SQL query in order to retrieve the data from these relations. Okay, then I give you the result, right? So it looks like the implementing of database management system too simple, too easy. Actually not. So now starting, as I mentioned here, just to give you an idea, convince you that if you have a doubt, implementing database management system is not easy job. Okay, and it's not simple as we imagine. Okay, in order to do that, I'm going to introduce you to the Megatron 3000. Breathe. This is an imaginary, fake database management system. We assume that, so it looks like we're thinking, since we said, okay, it looks like we have relations and statement, then we're gonna extract the result, so it's easy. I think the implementation of the database management system is similar to the imaginary system that I'm thinking about. I'm thinking our imaginary database is going to be implemented like this. So please, don't try it. In your CV, you said, I implement the Megatron 3000 database management system. And you're still wondering that you didn't receive any invitation or the job offer. Don't do this one. I saw some student did that. Don't do it. This is just an imaginary system, fake system. That's what we think, how the database is going to be implemented, similar to this fake system. Okay? I know it's confused because it said like Unix compatible, lightweight, cheap, and etc. We give you some today, but just fancy words just to give you that this is a database system that imagine the implementation is going to be similar to this one. Okay? So what I'm planning here, so it looks like we're going to rely on the file system to store the database. That's what I'm trying to do here. Okay? I think we cover this one. We talk about the database organization, the low level or the undergrad. We teach the database system or database organization to the undergrad student. We try first to tell them that we need to have a database management system. And the reason behind this one, and we cannot rely on the file operating system or the file system supported by whatever operating system, Windows, Java, Unix or whatever, Mac. It's not enough. Cannot give me the actual features that the database management system can do. Anyway, so assume that here in this case, the database, data can be stored as a comma separated value or ASCII. Simple thing. It looks like we have a file, yeah, for every single relation, each entity. We talk about the entity relation model or data model here, will be stored in its own file. For example, I have information about the student. So here we're gonna have a student file is called student. It might be text file, it might be whatever, yeah? And this file I can store my data. When you store my data here, I'm gonna say here, for every single line, I'm gonna store information that relate to the specific record. Yeah? You remember when you work with the Java, right? And the Java files in the Java, if you work with the text file, so in this case, you need to do what? You need to find a way in order to navigate your way within the file. You're gonna say, for example, for each line, I'm gonna store this piece of information. Since each line gonna contains information that belongs to different records or fields, I need to find a way in order to find separate this data from the second data or the other data. Okay? So again, the entity will be stored in the, its own file or relation. It's gonna be an own file. The application has to parse, in this case, in order to extract this information, your application must have to do what? Must parse the file each time it wants to read, or update a record. So I stored my data here like this, and what I did here, each table relation gonna has its own set of attributes. We do have the ID, the name, and we have the ID, and we have the department, right? In each file, different records are delimited by the new lines. So this is one record, the second record. And also, while each of the corresponding attributes, since we have 3 attributes, must be within a record are delimited by, let's say, special character. And I'm going to use a bound here. You can use a semicolon, whatever. Make sense? What does that mean? You say the application has to parse the file each time it wants to read or update the record. That means in this case, in order to extract this information, what we're going to do, you write your code in a way that extracts one line at a time. And for each line, you're going to do what? Find a way how to parse the contents of it. You can parse by, let's say, separated by, let's say, bound. So that means in this case, maybe you have one part. You have to keep scanning until you reach the first bound, this one piece, and the second, and the third piece of information. Make sense? So that way, if you have student, if you have instructor, if you have course, whatever data, relations, each of them can be stored here. And since we're going to use the Unix, so that's why we're going to use the user slash, for example, the subfolder, in order to store the data. Okay? And this is the schema, which is going to be the structure of the database, right? When we talk about the schema, we define this one. The first, slide, and actually the second slide in this part, slide on the notes one here, is defined as what? A definition of what the structure. You have to give me the structure or definition with the data that looks like. For example, you have course has 3 fields or attributes, the name, ID, and let's say the department. In the name, what the data type for each of them. Name, for example, string, or let's say char, or whatever here. Here we're going to use the string, etc., and integer in order just to simplify the process, okay? So we have a schema here, and this schema is going to what? It's going to, for every single line, it's going to be store the information associated with every single relation. So here we have a student. The first relation is the student here. And the student is going to have what here? How many attributes here? I'm going to use, the special marker card in order to separate or delimit, the attributes within this line or each line. So this is the relation name. This is the first attribute, bound, the data type. The second attribute, the data type, and etc. And this is for the second relation. If you have a more relation, it can be stored here. So what I did here, we simulate the way that we're thinking. Since we have a data, we need to store the data in the files That's what we did. And we need to keep tracking, have the information about each data, the schema, the structure. So we create a table or relation, called schema in order to hold all the structural description of the data. So now I'm fine. Yeah, it looks like we did the same job that's supposed to be done by the database management system. Okay? So this is the structure of the schema. Good. Assume that you launch your system, give you some fancy whatever. Okay. I think this slide maybe confuse the students. Say, oh, it looks like we have a real system. No, but it's just simulated. Similar when you launch SQL or MySQL, etc. Give you like introduction, Megatron or whatever SQL, welcome, blah blah blah, username and password. Then you give you the prompt. Then you can start typing your code. Quite maybe you can exit from this. Anyway, so let's take a look here. I'm trying to say here. Okay, we found a way to store the data. Now we need to find a way. How can we? Use this file system in order to retrieve the data. I think it's easy. Okay, so what we can do here, you can write your Java code which allow you to access the data, right? You can extract whatever piece of information. That's good. So assume that we can, when you write select star from the student here, you can, and the bound here used as to say the end of the query, we didn't have a semicolon. Just to have a weird stuff here. Okay, anyway, so when you say select star from the student here, what my actual code is going to be, maybe you're going to have a Java code or whatever, Python, whatever, in the low level. This code is going to be what? First, you're going to read the schema to check the student relation. First, that's what I'm trying to simulate with the database management system in my system. In order to say, I don't need the database management system. Take the schema first. I don't know why this one here. Okay, you ask the schema. Okay, check to get the attributes of this relation. In this case, get the attributes of a relation student. Yeah, how can you do this one? It's easy. If you take a look at the schema, you need just to read this one line by line, parse this one line by line, and you just, of course, the search is not, it's painful here, right? Because you need to read line by line, parse, but still doing my job. Give me the schema, the list of attributes associated with this relation. I can figure out what's the attribute there. Good. Once you get these attributes, remember, select the star is gonna do what? It's gonna display the attribute of the relation student first. That's what display them here. We're gonna be here. We have the let's say the name, the ID, and the department. Then after that, I need to access this file. Can I open this file? Yes. Text file, it's fine. You can write my Java code, access this file, and process every single line in order to extract the information that we have associated with every single attribute. Then just list them. I'm done. Okay, so it's doable. I didn't have a problem. It looks like my code works fine so far, right? Good. So now let's take a look, for example. Assume that the system allows you maybe to send the data to the printer. Yes. Can you do this, right? Your code to perform this operation? Yes. I can do this one. Instead, I'm going to read the schema to get that attribute relation student. Then after that, I display the attribute. Instead to display them in the screen, I just send them to the printer. Yeah, can I do this one? Yes. Okay. We can do this one here. Assume that we have the query that perform, let's say, selection. I gotta select filter out a tuple that doesn't satisfy a specific condition. Okay. And in this case, you can store this one. The only difference here, you can't do what? Here, you ask the schema student, check, for example, whether the condition is valid or not, because once you get access to student schema, I can't tell whether the IDs belong to this relation or not. Then if it's fine, what I need to do, I need to access the student relation, extract or pass every single line. I need to retrieve, find out what's the ID, compare with the ID less than 100. If that one, then I need to do what? I need to create or put this one in new relation. I'm not going to display the result. When you create a new relation, you need to do the same thing we did before. The only difference here, instead display the result after check the condition, if true, display the tuple, I'm going to store this one in the file. So create another file called the low ID, and this file is going to store the same information that, whatever information you need to store. Then make sure that you create or add one entry in the schema that contains, the structure of this file, the new relation that you just created. So here, that's what we did actually. This is, the structure or algorithm that you're gonna follow here. Read the schema, select the start of the relation R, check the condition, whether it's valid or not, make sure the attribute that belongs to the relation R exists here, or I'm not going to use an attribute does not exist. If fine, I can display the attribute at the header, then after that you read the entire file, relation R file, line by line in order to display all the attributes, of course, after the conditions evaluate to the true. Make sense so far? So it looks like right now we didn't have a problem. Yeah, I managed to do, the basic features of the database management system. So right now, I don't need the database management system. If you try to do this one in another table, that's what you did. You just to store the information on another file, and you need to add one into the schema. We did that, okay. Here, what if I try to join two relations? Remember, those, core is not random, because we're gonna now, after a few, later we're gonna take a look at them and say why they are not efficient, why there's a problem. So assume that we need to join the relation, to get data from two relations. In order to perform that, get the data that belongs to a relation, you know that the basic thing you're gonna do what? You have to join them, right? So what we did here, we're gonna do a Cartesian product, join them, and this is here, we have a simple way to join two relations. So this is, what's called the nested loop, or the Cartesian product when you join two relations, or data from two relations. The simple thing we're gonna perform here, you ask the relation R. For each tuple belongs to the relation R. What you need to do here, you have to ask the relation S. Each single tuple belongs to the relation S. Then you join this tuple with every single tuple of the relation S. Yeah. Then you check the condition is true, because we have a condition based whatever join algorithm you need to perform here. Then you can concatenate them. Then you're going to be part of the result. All right. Here you need just to attribute A and B, so you need to just project these attributes. The problem with this one, for every single tuple of relation R, I'm going to ask every single tuple of relation S, or ask the entire relation S. Okay. So if you have n tuple belongs to the relation R, and we do have, let's say, if you have n tuple belongs to the relation R, or n record or line, let's say line here because we have lines, and m lines of relation S, we have to perform n multiply m operation. It's costly, right? Especially if they have a large amount of data. So the question here, what's wrong with what we cover so far? Why this is not working? Why is not efficient? Why is not it's not good idea? Why we need the database management system to take care of this one? So let's start with the problems that we have here. Yeah, the first one here, the way that organize your data on the disk is bad. I'm relying on the ASCII. Yeah, I said for every single table or each entity has its own set of attributes. So for each file, what I need to do here, we have a different records, and for each record going to be separated by or delimited by the same new line, and for each of the corresponding attributes within the record are going to be delimited by the special mark. And every time I need to access one, I need to parse line by line. That's a bad idea. The way that we organize the data is not, or we call this one, the layout of the data. We have a better way to lay out of the data. Relying on this file system is bad idea. We cannot do this one. I think the time is, okay. Yeah, I'm not going to take extra time. So I will stop here. And next lecture, I'm going to go over this one. Start from here, okay? So we're going to finish the rest of the slides. Then after that, go to the next one. I'm going to take a look how the data be stored in the desk, because we want to work on the desk oriented database management system. Then starting looking at the file storage, etc. That's all, guys, for today. And see you, I'll talk actually to you on Wednesday. Enjoy the rest of the day.